In this tutorial, we will learn to define glazed elements in BISTRA. We have developed the BISTRA project from the previous tutorial by adding a double glazing panel. You can create this with Bisco or by directly loading a DXF file. We now zoom into the glass at the macro level. We can subdivide the glass panel into two sides to assign distinct properties for the glass facing the boundary conditions. If the radiation is falling along the direction of side 1, then properties such as solar reflection, absorption, transmission and emissivity for infrared radiation along side 1 will be considered. If the radiation is falling in the direction of side 2, then the corresponding properties of side 2 will be considered. Properties defined within the color from the direction where radiation originates remain until the next boundary is reached. Therefore, inserting a transparent material surrounded by other transparent materials doesn't affect the radiation properties. Only the properties defined for the color from the side where the radiation originates are used. So we could add any number of glass or layers between these two panes of the glass. But it's important to note that adding opaque materials surrounded by transparent materials results in absorption and reflection of solar radiation within the element. For this example, we can split the outer glass into two panes so we can define the low E coating to the inner side of the outer glass. From the Colors menu, choose List Defined, say we wanted to define the inner side of the outer glass with color 19. From the Bitmap menu, choose Bisect. Next, click in the color that you want to vertically bisect. Here input color number as 19 for newly created layer and choose Vertical Split. Upon clicking OK, we see the glass panel bisected. Now we need to input the parameters at the Colors window. Firstly, we change the cavity between the glass to transmat and the cavity between the glazing panel and wall to BC free. This would perform the analysis using the radiosity method, which is explained in detail in the Colors tutorial of Bisco and also BISTRA. An important note is that in Physibel software, we define the solar transmission factor after subtracting the reflection. The description for each of the parameters is also available at the left bottom toolbar when clicked on it. You can input the properties of the double glazing system from the manufacturer's data sheet or other sources. For this example, we refer to the LBNL International Glazing Database. Here, we have a double glazing unit with an air-filled cavity. For each glass, we see the properties of side 1 and side 2. The inner side of the outer glass, that is, side 2, has a low E coating. This is reflected in the emissivity, which is much lower than that of side 1. Here, we see the solar transmission for side 1 of outer glass. Here, we see solar reflection and infrared emissivity for side 1 and 2. Similarly, we have data for glass 2. In our example, we have the same properties on both sides of the inner glass, so we don't need to subdivide it as side 1 and 2. So we just define it with one color 20. For the two sides of the outer glass we input the properties from the LBNL database. In this, we just need to calculate the transmission factor after the subtraction of reflection. In addition to this, the reflection for the outer pane, adjacent to a solar zone, can have a reflection as a function of the angle of incidence of solar radiation. We can define this using a function, discussed it in detail in the functions tutorial. For this example, we limit ourselves to a constant value. It is also possible to have a PVB layer between these layers of glass. Although this wouldn't affect the solar properties, it can be of interest to have this layer in, for example, to track its temperature. We can draw a layer in between directly. From the Colors menu, choose List All. Here, say we choose color 7 as it's not defined and not yet used in the model. Choose the Draw tool and click on the start point at the top, hold Shift and then click on the bottom point. So now we have a line between the glass layers for PVB. The properties of it would not impact the analysis as long as it's transparent. So, ensure the transmission is a non-zero value. If it is 0, then it would turn to be an opaque layer and absorb the solar radiation accordingly. We can keep the same properties for the PVB layer as that of the outer glass pane. Click on color 18 and then from the Colors menu, choose Copy Row. Then click on Color 7 and then click on Paste Row. We now input the name of the color as PVB layer. Next, click on Report Definitions. Click on Insert After for a new definition. For Color 7 for the PVB layer, choose Theta Max. Then, for Color 193 for the air cavity between the wall and glazing panel, choose Theta A, to track the convective temperature for the cavity with type BC free. We now click on Calculate to run the analysis. Upon completion, click on Text Output and open the Results tab to check the results for calculated parameters. Thank you for watching, see you in the next tutorial.